Hello everyone, this is Clifford Kian from Peas and Chips Productions. Welcome back to my Unreal Engine game creation breakdown series, where we will be breaking down the making of a game from initial concept to final product using my recently created game USEU Arena as an example. In this series, we are currently building a VR shooter prototype, and the previous video covered snap turning and bullet creation. So, check out that video if you missed it. In today's video, I will be creating an enemy for the prototype. The enemy will be able to be added to a level, be able to track the player, and be shot by the bullet we created previously. So, let's get started. I'm now going to create a new blueprint for our enemy, and it is going to be based on the actor class, and I'm just going to call this blueprint BP_enemy. And we're also going to make this a physics type object. So I'm going to add a box collision component, and we will make this the root component of the blueprint. Because we're going to make this a physics object, we once again click the simulate physics checkbox. And very similar to our pawn, we're going to lock its position in the Z axis, and we're also just going to switch off all rotation. So it's going to stay pretty much upright and in the same position. Under the collision, I'm just going to switch off that the character can't step on it. It's not really going to be relevant to us. I'm going to switch it to a custom type preset and set the collision box to a physics object. And we're just going to, by default, set it to ignore everything except for the static and dynamic type objects. So it will be able to interact with the background, and if a dynamic object like our bullet interacts with it, it will be able to react physically as well to that. Then we're going to add a visual component to it, so a static mesh. And once again here, what we'll probably do is make this box very similar to the bullet. We'll use an existing cube static mesh, 1 meter cube. And then we're just going to resize these things appropriately. So a good value for me here, I think, was 0.63 in scale. Now, the static mesh is the thing that we're actually going to use to check for whether the bullet has actually interacted with it. So in this case, we set it to a query type of collision, and we'll want it to interact with a bullet. But we'll need to create a object type for it. So we'll have an enemy object type and a bullet object type, and we'll basically only allow bullets to overlap with enemies. So we're only checking against two types. But before we can do that, we need to actually create a new object channel for it so that it knows to query against a bullet to an enemy and an enemy to a bullet. So by creating these channels, it allows your collisions, collision checking to only check against those types instead of having to check against 10 other different types it's just not interested in, which obviously makes it more efficient. And also to allow specific action checks. So here, once we created an enemy object channel, we can actually set our channel to a type, object type of enemy, and we say that it should only overlap with a bullet. Now, overlaps are a bit different to physics objects, as they just check for overlap and they have no physical interaction. Basically, once the overlap, you can create an event for it, but they don't react physically. So now that we've added the collision, we now want to just add our behavior to our enemy, and so I'm going to create a new function called track player. And what that's basically going to do is find the location of where my current enemy is in relation to the player pawn location, and then basically set a direction towards that, creating a vector or a velocity towards that. And we simply get that direction by getting the player pawn location and the enemy location and subtracting the two locations to each other, which will provide a vector pointing in the direction of each other. So it will be a simple subtraction of the two vectors. And then we'll be able to eventually use this to set a linear velocity in that direction. So very much like the bullet, if we've got a physics object, we can use the set physics linear velocity. And once again, like the pawn, we are actually will only be interested in the x and y components of the velocity and not the z. So that's why we actually just making the vector from its individual components. So we're just normalizing the vector that we've calculated. So it's just purely a direction vector, and once again I'm going to now create a speed variable which we can then multiply that direction vector by. So this will give the enemy a very particular speed that it will move at, and I think the speed that we'll set this one to at is about 400. Finally got it dragged on, and we then break up those components to x, y, and z, because we are not really interested in the z component of this velocity. We map the x and y components, and then we connect the execution node to this. So I actually tested this out, and I actually got the directions of the velocity is incorrect. So I've just swapped around the pawn and the enemy's location in the way that they subtract. So now we want the enemy to track the player. So in this case, I don't want to track it every single frame or all the time. I'm just going to let it track every, say, 3 or 5 seconds. So we set a time, creating a new timer called, it's going to then call the track player function. And I'm just going to create a variable for how often I want it to track. And so it will track the player every 3 seconds. So it will reset its direction every 3 seconds. It's going to move towards where the player is, and then wait 3 seconds and check where the player is again, and adjust its direction. So we set the timer function to looping, which means that it will run every 3 seconds. If you don't set it to looping, it will only fire off once. Okay, so let's just give it a very quick test by adding the enemy directly into the level. We're not dynamically adding or spawning the actor in this case. It's being placed as part of the level. And there we go. The enemy is facing you. And there's our bullets shooting at it, but we haven't built an interaction yet, so the bullets just kind of bounce off the enemy due to normal physics collision. So we need to adjust this bullet to now allow the interaction with the enemy. So first off, we need to set I'm going to set the static mesh to allow query conditions. So this allows to check for overlaps. I'm going to set this object type to a bullet, and it can then overlap with objects of type enemy. So that's what the checkbox over there does. But before the overlap can actually even occur, the physics objects needs to be smaller than the actual overlap mesh, or else it's simply going to bounce off it and the overlap will never occur. So I'm just going to resize the box extents, or the size of the box collisions, to 4.8, which is just slightly smaller than the actual static mesh cube. And then the other thing that we need to make sure is that the static mesh cube actually has some sort of collision bounds attached to it. And we can see that actually it does already have a simple collision attached to the mesh itself. You can see by the little green outline that we had seen, but you can also check out the collision there under the primitives. It's got one primitive there, which is just really a box. And you can create many different types of primitives to make up the collision on your static mesh. You can also create collisions purely based on the mesh as well, which is complex collisions. This one is just basically a box shape. So now we need to check that the generate overlap events on both the bullet and the enemy have been ticked. This will allow the Unreal Engine to create events for when an overlap occurs between these two types of objects. So we're going to create an event here for the begin overlap between one of the objects. We're going to do this on the enemy. So as soon as one of those conditions have been met, an overlap condition has been met, that event will actually fire off. And I'm just going to create a function here called hit, which will destroy the actor. And then I'm going to connect that to the overlap event. So the only event that's really going to fire, because we have set it up, is a bullet hitting the enemy. So I don't have to check what the other actor that's overlapping or the other component is. I know it's going to be a bullet. And there is our enemy, and we're shooting, and there a bullet actually hit the enemy and then destroyed itself. So that's it. So that was a good test, but part of what my prototype that I actually want to do is so seeing what it's like shooting lots of enemies was really part of the prototype, just to see and to feel what that gameplay would be like. So I could place a whole bunch of enemies in that level manually, but I'm actually going to just create a little function here to keep spawning a bunch of enemies around where my current pawn is. I'm just going to do this within the pawn itself, because this is a prototype. Just the easiest place to put it. You obviously wouldn't put this here in a production environment or code. So I'm going to create a variable as well, just to store the number of enemies that I would like it to create at any one time. And I'm going to create 8 enemies. And I'm going to add a simple for loop, so, which will go from 1 to 8. So it'll loop 8 times. Sorry, for loop takes integer, so I've just changed the variable type to integer from a float. So now within the for loop, what I want to do is spawn an enemy. So I once again use that spawn actor from a class, and we specify the class to be an enemy, or bkey underscore enemy. Loop that we created. We connect that up to the body of the for loop. But now we want to place this in a kind of random area that just sort of surrounds the pawn. So depending on where the pawn moves, I want to randomly create enemies around the pawn character. And we also want it to be placed at the correct Z level. But so the way we're going to do this is we are going to get the location of the pawn and then find a random value or location for each of the components, the X and the Y components, that's a positive, say 800 or so distance away from where the current pawn is, in the positive direction, and a negative value for in the opposite direction for, let's say, the X and Y component. So essentially what happens by doing that is you'll create a sort of random box area that surrounds the character where an enemy can be spawned. And to do that, there is this nice little function called get me a random float within a range. So I'm going to set a minimum range of, let's say, 800 and a maximum range of negative 800. Actually, those values should probably be in the opposite direction, but I think this still works, as in a minimum of minus 800 and a maximum of 800. So it'll be 800 to in the X component, or negative 800 anywhere within that range, and similarly I'll do that for the Y component. And the Z value there has been set to 300, which will be more or less in line with the character pawn itself. Let's compile and save that. And then how often do we want to actually spawn these enemies by our character? So in the event begin play, we're going to once again create a timer function to set the frequency by which we're going to spawn the enemy, simply by calling that the spawn enemies function. So in this case, I think that every 10 seconds or so gives you time to shoot the previous ones before new ones appear. Set that to looping, and we'll set that to looping, so it's every 10 seconds. And we're calling the function within this class. That's why I set it to the self. Now let's give that a test. So this was our existing enemy, and then these are the new enemies that are appearing a little distance away from your pawn, and we're shooting and we're able to hit some of these enemies. You'll notice that some of the bullets bounce off. This is because they're moving a little bit too fast, and the physics happens before the actual overlaps. So it's not perfect, but there is enough in this prototype to get a feel for what it's like. Having multiple enemies coming at you, your character has movement, and you can shoot, and basically you can shoot them. I can definitely feel that the main concept that I was trying to test it was definitely worthwhile. It is something that can be built upon. Thank you for watching today's video covering the creation of an enemy for our prototype. The next video will cover the evolution of the game's architecture and class hierarchy. Get a view of what a real-world programming structure may look like. So, don't forget to like and subscribe to continue on our journey on breaking down game creation from initial concept to final product. See you then!